Welcome to another episode of Complete Developer Podcast, the podcast by coders for coders about all aspects of creating your best life as a developer.
I'm Will, the accomplished developer and aspiring software architect.
And I'm Beej, the journeyman developer, sharing my journey in development.
Complete Developer Podcast is supported by listeners like you. We are now on Patreon at www.patreon.com/Complete Developer Podcast.
A lot of us learn to develop software using object-oriented programming, or OOP. This model somewhat fits the way a lot of people look at the world and works really well in most cases. However, over time, you'll start to notice situations where a naive understanding of OOP is just not enough. In this episode, we're going to talk about some of the things that will plague you as you take OOP to the next level. But before we get started, Will, what have you been fighting this week?
Well, I have a book deal, as people probably know, and trying to get that project moving is taking a minute. You know, everything always takes longer than you think anyway, but starting it out it's taken a couple or three more weeks than I thought that it would just to get going and start getting a feedback loop. So I've got that. I've got a lot of stuff going on at work, and we have a lot going on with the podcast. And so basically I am working from when I get up until I go to bed a lot of times. I'm not getting a whole lot of breaks. So it's just really been pretty stressful. I'm also going to the doctor a lot. I'm turning 40 this year. And so I decided I probably ought to start being a little bit more intelligent about my health stuff. I don't have any major stuff going on other than grinding my teeth at night, which is kind of frustrating. But, I'm getting to an age where I need to be handling this stuff. So all that's going on at the same time. So how about you?
Well, I am exhausted. I've got some of the same stuff as you with the podcast, but I've also been getting up a couple of hours earlier than normal to catch the bus into Nashville. We're interviewing junior developers this week, and so I've been going in every day. And I had Monday off, but I spent all day working on stuff in the house. And I got to the end of the day and was like, man, where did the day go? And then I looked around and I saw all the stuff I'd done on the house. I was like, well, I got a lot done, but I just felt like it just went by too quickly. But, life's been hectic since the move. I did get my furniture and the bedroom and kitchen, living room all set up. Then my mom bought me a new TV stand for my birthday. I still have to set that up because I had to take it back because one of the sides was busted when I took it out of the box to assemble it. My office, as Will can see, is still in progress. I do have my bookcases up and I got a rug for the floor, but need to get some sound dampening panels and a few other things. Also, I'm going to have it looking decent by next weekend when I have my birthday / housewarming party. Now, this episode is coming out just a few days before my actual birthday, but I eventually plan to go through all the boxes that I have here and in storage. I'm going to throw away a bunch of stuff. Still figuring out what to do with my spare room. Right now, I have the futon in there and a desk, and it's sort of like a multi-purpose room. I've got my easel in there. I've got my guitar in there. So it's just sort of a hobby multi-purpose room now. One thing that I'm getting used to, though, is not being connected to anyone. In the apartment, I didn't ever turn on my heat because the other units around me kind of kept it warm enough, and I like it a bit cold anyways. That said, I have something interesting for the smart home in IoTs. So this is a product called Keen Smart Vents. These IoT-enabled vents adjust the airflow to a room based on metrics from that room specifically. It's kind of like having individual AC controls per room, but instead of controlling the temperature of the air, they control the flow of the air into the room. The sensors and an app on your phone allow you to set up schedules for rooms, to open up vents, and even set room temperatures based on the airflow into the room. This is probably one of the more useful devices in turning an older house into a smart home and can be used in conjunction with a lot of other smart home devices. So I'll have a link to that in the show notes. Will, who's talking to us this week?
Well, we got an email from Jason, and he says at 5125 in the Resume Driven Development Show, Will talks about a junior dev job hopping after completing an assignment to get a better job. And it sounds like Will believes this behavior might be a mistake for a mid to senior level developer to do the same. Please clarify. Thanks for the show. I enjoy listening from Central Florida. Okay, so I'll go ahead and answer this one. The deal with job hopping, as a senior developer, you're paid more. And an employer is going to look and go, okay, if you're job hopping too quick, they're looking at how frequently you do it and going, look, this guy switches jobs enough that most of his time is just learning the new system, not actually being productive. And so that can kind of be a negative. The other thing is you kind of need to stay put for a while in a lot of cases, just so that you get deep experience somewhere. There's a lot of senior developers that jump around like every year or so. And one thing that you'll find is they have a broad experience, but they don't understand what happens after 3 years of doing something a certain way. And they don't have that viewpoint, and they can't see that stuff that potentially could come up, and it just makes you better. Now, I also do think you need to jump around some. That's the best way in the world to get a pay raise. But, you just kind of have to balance it a little bit more carefully than maybe a junior dev would have to do.
Yeah, I agree with that. So, Jason, send us another email with your contact information, because we've got a Complete Developer water bottle just for you. Guys, if you'd like your very own Complete Developer water bottle, leave us a review in iTunes or comment on the website or any of our social media. We post all our episodes to Twitter, Facebook, LinkedIn, and Google Plus for the 5 members still on there. We also are on Instagram and Tumblr. You can check us out each week on Facebook and Twitter Live, where we talk about what's going on in the tech world and answer some listener questions. Or join the conversation anytime via Slack by going to slack.completedevelopernetwork.com. Per techtarget.com, object-oriented programming, or OOP, is a programming language model organized around objects rather than actions, and data rather than logic. Historically, a program has been viewed as a logical procedure that takes input data, processes it, and produces output data. The idea is to attempt to model the real world in software in a way that assists in understanding the system that the software is attempting to model.
Now, let's go with a couple of quotes to kind of kick this discussion off. Here's the first one. Object-oriented programs are offered as alternatives to correct ones. Here's another quote from the same guy. Object-oriented programming is an exceptionally bad idea which could only have originated in California. Now, this sounds like a pundit. However, this was Edsger Dijkstra that said this. So it's a little bit more of a big deal.
We also have a quote from Linus Torvalds, the creator of Linux, that says, C++ is a horrible language. C++ leads to really, really bad design choices. In other words, the only way to do good, efficient, and system-level and portable C++ ends up to limit yourself to all the things that are basically available in C. And limiting your project to C means that people don't screw that up, and also means that you get a lot of programmers that do actually understand low-level issues and don't screw things up with any idiotic object model crap.
Yeah, and Linus is known to be blunt. That's a feature of the man. The thing is, OOP has its detractors, some of whom are definitely worth listening to. And even among those who really like the paradigm, there are spots where they will admit that OOP can make life difficult. It's not that the code is necessarily difficult, although it can be, but that system models get more complex over time as your understanding of things improves. As a result, it's very easy for an early, naive implementation to paint you into a corner, and it's hard to get out of that corner.
So we're going to get into a few of those, and we'll go ahead and warn you that there are going to be a lot of Will-isms in here. He wrote that, by the way. The episode is not intended to be an indictment of object-oriented programming, but rather a set of issues you should consider while attempting to use it. We're going to try to keep the examples fairly language agnostic so that the conceptual problems jump out rather than the implementation issues.
So the first problem is the misuse of inheritance. I've got this titled as the mammal problem. Inheritance hierarchies are fuzzy in the real world, yet OOP tends to require them to be more strictly defined. For instance, a veterinary clinic might use a mammal abstraction in the context of the practice. A developer who doesn't have all the required information might well derive the class of receptionist from the class mammal. While technically true in the real world, it creates problems as a programmatic abstraction. So,
right, because humans are mammals, but you don't want to classify your workers in a veterinary office as patients.
Yeah, I mean, it's really easy to say things that are technically true in your abstraction that are not true in the world of the program. You're basically creating a work of fiction when you're doing OOP.
So everyone listening to this podcast is the product of two parents, an educational system, and a set of life experiences. However, it would be hard to conceive of a base class that could only apply to just those. Lots of people may have kids of their own, different careers and aspirations that add a lot of additional data. However, it's very easy starting out with OOP to try and create a model that actually handles all of that.
Yeah, the real world is extremely messy, especially across contextual boundaries. The meaning of words has to be agreed upon from the get-go to even have an intelligent conversation. I mean, half of our politics is people that disagree on the meanings of basic words. And just to put it in OOP examples, a goat farming school teacher has kids in 3 different contexts, potentially, which have varying degrees of overlap. An abstraction trying to cover all 3 is doomed to be a failure. However, if you've got a user describing this to you, and how the model works, they may say having kids, and you take it one way while they meant the other. And so it's really important starting out with OOP to get your terms right, because it doesn't work the same way.
You really, really need to strictly define the word is.
Yeah, legitimately.
I was making a reference.
I know. But I mean, trying to think about that conversation in OOP terms.
Yeah. Deep hierarchies make code brittle. Think of a hierarchy of living things and assume that mammal is a base class, on top of which a series of other classes is layered. So what happens when a developer doesn't know about marsupials? They keep their young in their pouches. And monotremes. These are mammals that lay eggs. And you have to backfill that behavior because these are sort of oddities in the mammal world.
Right. And how do you handle cases that don't fit neatly? That's another problem in OOP. For this hierarchy, how would you handle it when your software suddenly has to support things like synapsids and therapsids? These are extinct mammal-like reptiles or proto-mammals. They have some of the characteristics of reptiles and some of the characteristics of mammals. It was a missing link.
Yeah. How do you handle these edge cases? While these examples are not things that you're likely to come across, you'll come across similar deep but brittle hierarchies in systems that you work on. I mean, this happened to me not that long ago where we had to completely change the data model on a project I was working on.
Yeah, because you didn't have a definition for is. Really? I'm being 100% not facetious on that.
What happened was we had these 2 objects that we were told were completely separate. They're entered separate, different people touch them, and they're only kind of tangentially related to each other. And then we come to creating the reports for them, and we find out, oh, yeah, for the stuff that they actually need this program to do, not entering the data, but like actually using it, these things need to be connected. They have to be a part of each other.
Yeah.
And so we had to rewrite a good bit of the data model to make that happen.
Yeah, and this happens all the time. Now, another thing that happens is multiple inheritance, which is really tricky to work with. A lot of OOP type languages don't even support it. And you have to think about situations like, what do you do when the same entity is a customer and a vendor? And the most obvious option is to simply make them separate entities. but that gets really tricky when you need the features of both. And you could also say, okay, well, I'm going to make an object that's kind of a chimera that understands its context and presents the correct behavior in different situations. It's kind of, your object has to live a double life. That gets complicated.
You end up with a lot of flags there.
Yeah.
I've tried to do that on projects I've done in the past. A while back when I was still learning a lot of stuff, and it got nasty real quick.
Yeah. And the next option is for the consumer to have deep knowledge about your object so that it can do the right things with different object types. And in that case, why have the abstraction at all?
The next situation that we're going to talk about is the misuse of polymorphism, or the electrical outlet problem. It's easy to get consumers of objects and the objects themselves out of sync in regards to their expectations. For example, we're going to talk about an electrical outlet as something that exhibits polymorphic behavior.
Yeah, and I've got a story about this. I worked for a company that made medical carts, and I was working on a battery management software package. And so I had to detect, the cart would send a message in when it was plugged in, when it was unplugged. It would send status messages about the battery, those kind of things. And I had a couple of carts that I was using to live test the system. Well, it turns out that, these were prototypes and they were still working on them. And the DC out plug had the same form factor as the AC in plug. So essentially it was a polymorphic interface between things that did not have the same expectations. And to make a long story short, I plugged mains power into a DC out plug that was expecting I want to say it was 5 watts or something.
Did you see that machine's magic smoke?
I did. The room was filled with magic smoke. But the thing is I did it to both machines because I plugged one in and plugged the other one in. It took a second for it to be too much and, burned up some hardware, frankly. And that's real easy.
Well, I mean, you guys remember me talking a few weeks back about burning out my mouse and keyboard because I plugged the wrong adapter into my USB hub.
Yep.
I ruined speakers, keyboard, mouse, and a couple other things. Nothing irreplaceable, but it was just annoying, especially when it was working. I leave the room and I come back and it's not working. And I finally figured it out, and it was it had been plugged in for days.
Yeah.
Before that actually happened. So yeah, it can be really frustrating, especially when it happens all of a sudden.
Yeah. And polymorphism lets you treat different things like they're the same as long as they don't act different in a substantial enough way to cause a problem. With multiple people touching stuff, this guarantee is really hard to maintain.
Uses of polymorphism can expose large portions of a code base to changes that would otherwise be isolated. So if a piece of functionality has to be added to two types that don't have the same parent type, it's common to add it further up the chain for polymorphism.
Yeah, this can force you to account for it at everything below that type and every consumer of the same. And this can bleed a lot further out into the code base than you might originally think. It's kind of like in a building's electrical system. If you take the input amperage and you crank it up, that means all the wires, all the circuit breakers in the building have to change. And that can also be true of everything that's plugged in, to every power outlet in the building, potentially everything that's plugged into everything that's plugged into the power outlet. And you get these same kind of changes going through your code base because you made a change for polymorphism and now have to support it in lots of places.
Yeah, in some places it's not supportable, so you have to create an exception for it.
Yeah. Or you have to add something else to the interface that acts as a flag and then check for that everywhere. And then you've got polymorphic inception at that point.
Right. Yeah.
And there's a reason I'm saying that that's a thing. It's because I've done it enough that it really hurts and you don't want to go there.
Yeah. Which is what happened to me when I was talking earlier about multiple inheritance stuff and the creating the flags. It got crazy. Polymorphic code trends toward handling things in general when specificity is a bit more reasonable. When polymorphic calls make polymorphic calls of their own, the temptation is for the first call to take parameters that are as general as possible.
Yeah, and the fun thing that happens there is that means that the second call is either forced to deal with a general case or is forced to probe for a more specific case and then dispatch accordingly, possibly meaning that it will break polymorphism when new, more specific behavior is added, for stuff that's downstream.
Now let's assume that your outer call takes an innumerable bunch of objects because it just needs to loop through them. Then we'll also assume that the inner call needs to get a count that it returns as an integer. Well, using enumerable, and this is something that I have run into, instead of a list means that a caller of the outer method can pass something in that has a count greater than an integer can hold, or that is subject to network errors. And boom.
Yeah. Or something that doesn't terminate, right? Like it could be a sequence that's reading off an IoT device. And as long as that device is plugged in, it's running. Well, if you try to get a count of records when there's however many, they're going forever, it's not going to go well.
So the next situation is bad encapsulation. This is the dinner discussion problem. That's kind of funny in its own thing. The insides of a class must be protected. However, different degrees of protection are appropriate in different contexts. For instance, in conversation with a spouse, there is a lot of stuff you can talk about. Hopefully. Yeah. Some of which should only be between the two of you.
Hopefully.
Yeah. I mean, Will is married. I have been married. And there are things that I talked to my ex-wife about that I would not talk to Will about.
Thank goodness. But the thing is even if you're talking with, your spouse, there's stuff that you say, when you're talking and you're in your house versus what you would say at a table in a crowded restaurant, right? It's not just the consumer, it's the security context, if you will. And there's lots of stuff that you're not going to say with some rando that you met at the gas station that you would say to your spouse. In other words, exposure levels of various fields vary by context in complex ways, and most of your OOP-based languages really don't enforce this to in the way that you need it done.
The granularity of exposed data doesn't always match the way that the data is validated. So the way properties are exposed, at least in naive implementations, doesn't correspond to how they're altered.
Right. Like, for instance, there are multiple components to an address. However, it's almost certain that if you move to a different state, that your street name probably changed. So if you don't break state mutations into reasonable chunks, in other words, hey, change the address to this versus just change the state, your objects will transit invalid states on the way to valid ones. You change the state and you're about to change the street address, but an exception happened.
I will tell you the most frustrating thing for me is, you've got Chrome has that autofill.
Yes. And it does it all the time.
Well, you can turn it off, but I like to use it because, I can start typing my address and it's long, so it'll autofill and it'll fill in all the places. Well, if they have named like the zip code something funky, or they've got like some weird restriction on it, sometimes it will not fill in the zip code. So what happens when, say, I moved and I'm going in to change my address? It has the old information in there. I type in my new information, autofill pops up, I select the right one, and it fills everything but the zip code.
Yep.
Not that this has happened to me anytime recently.
Right. Not like you moved or anything.
No, not at all.
Yeah. Now, here's another fun one. Encapsulation can also play havoc with inheritance, especially across library boundaries. So you may want other classes that you wrote to inherit from a given class to be able to get sensitive things like encryption keys, other protected data, that kind of stuff. But you don't want just anybody to be able to inherit and get at it. And by the way, this is a bad example because, there's other ways to keep passphrases, but anything that's kind of sensitive to the running of the system, like even event hooks, those kind of things you can break a system. So you don't want to expose them. But let's just roll with this. You might want to expose a class to classes in other libraries, which means that even if you have library-specific protection levels, stuff like internal in C#, you still can't enforce your rules because the language won't let you.
Next is database and persistence issues, or the family filing cabinet problem. You have to consider how an object will be stored in either a relational context or in a file. This is okay when it's a simple object, flat table, that kind of thing, but it gets interesting and complicated as you add polymorphic members and nulls to it. So I recently, as in today, ran into a bug. We're in the process of migrating old data into our new system so that they can completely replace it when we move it to production. Completely replace the old system, that is. And the one piece is like 3 levels in, got assigned to the wrong thing. And it had the grandparent object ID on it because of the way some of the search function worked to make it faster. And so it had the wrong one of those. And it was just a migration issue, but it was breaking everything. And it took hours to figure out, because it was only happening in 1 or 2 places. These 1 or 2 things got the wrong data put into them.
Yeah.
In one field. That was it. Just one field broke the whole thing for those particular instances.
Yeah. And
so, yeah, it's tricky.
Yeah. Polymorphic serialization is no joke, especially with deep object hierarchies that have their own polymorphic members and, arrays or lists of those things. This also means, as you're persisting things, that you have to deal with versioning issues of your objects. So the serialized form of an object from a version of your app a year ago is different than the same thing today. This is the problem, by the way, that plagues things like MS Word with reading stuff out of old versions. They can't sometimes because of this. And it means that you have to do stuff like fill in extra, fields that have been added with some kind of sensible default, or ignore stuff that isn't there anymore. And that can be really painful.
Complex object graphs will also have the risk of circular references or of containing things that can't be serialized and deserialized. My issue was a little bit of a circular reference because this was the object that I talked about earlier that had been separate and then got put in. And so when it was separate, it just had a reference back to what became its grandparent object. But as an example, let's say that you are recording a family tree. You have a couple parents, their kids, and their grandkids. If the parents have a list of their kids and the kids have references to the parents, you can traverse the graph in a loop forever.
Yeah, and you also can't just keep track of object IDs and try to avoid duplicates either, because if you go far enough back, everybody's family tree is no longer a tree. It's a directed acyclic graph. And that means that it's tangled. It's a family hedge. And then inheritance also makes serialization even more fun, especially with polymorphism thrown into the mix. A parent is also someone's child, possibly someone's sibling, and likely someone's spouse. If you model this poorly and your language doesn't transparently cast things, you'll have to preserve metadata so that you can do it yourself.
Then how do you serialize a diff? Let's say a wife passes and the husband remarries. There are kids from both marriages involved. And then the husband passes away and the wife remarries the new wife. How do you store this so that the now orphaned nodes get serialized and deserialized? And aren't there like a lot of fairy tales about this kind of same thing?
Yeah.
The evil stepmother.
Yeah, it gets real weird real quick because it's not just, hey, here's the state of these objects, but here's the state over time. And you've got to look at it completely different than you would in the object model, potentially.
Yeah. How do you tell when something has been altered from the last time it was stored? You're going to need this to cut down on a lot of noise in your audit trails.
Yeah. And that's a whole nother can of worms that we should probably do an episode on one of these days. But audit trails make everything worse. Now, the next one is concurrency nightmares. And this is like the joint property problem or the joint bank account problem. If more than one thread has access to your object and the object state is mutated on one thread without synchronization around it, it can cause weird behavior on another thread. This is the sort of thing that leads to race conditions.
So a good example of this is a couple's bank account. Now, we've used this example in a few other episodes as well. So the husband buys a boat and the wife buys a car. Depending on which transaction hits first, you could have an inconsistent number of overdraft charges. Now, Bank of America took advantage of this a few years ago and put transactions in an order that would maximize the overdraft charges. I know I got burned by this because they would put your debits before they would put your credits in.
And they would put it in order from the biggest debit first as well.
Right. So if you say took your paycheck in, because this is back when we got physical paychecks and not direct deposit, you take your paycheck in, you give it to the bank, and then you go pay your rent and you go to the grocery store, and then it's Friday, so you go out to the club like we used to do down on 2nd Avenue. Woo woo.
Oh, Lordy.
But, and you get these charges. Well, what they would do is go, oh, you paid rent. We're going to take the biggest one out first, and then we're going to take all your other debits out, and then we'll add your paycheck in. And it ended up like they were... Like, I got burned by this a couple of times, and I had to call them up and say, what's going on? I deposited my paycheck 3 days ago, didn't spend any money, and now I have overdrafts because you guys took so long to deposit my pay.
Yeah.
You remember when that happened.
Yep. Now, it gets worse. When you got multiple threads accessing multiple objects and using synchronization mechanisms, it requires a lot of extra care to avoid deadlocks. Now, I'm going to try to explain deadlocks in a way that people get it. It's hard, but visualize 2 lanes of traffic going in opposite directions on crowded roads. And we're going to treat the road space kind of like it's a shared resource. Obviously, it generally belongs to one lane or the other, except when a left-hand turn is happening. Again, in the U.S. Brits, you're going to have to kind of do things.
It's a right-hand turn for you.
Yeah. 2 cars simultaneously start to turn left, in the 2 lanes of traffic, down from each other. Each car is depending on traffic in the other lane to clear to be able to turn left. One lane gets blocked further ahead, say by a wreck, and no one lets the car turn in the opposing lane. And eventually there's no space to move. Barring a median or somebody just deciding not to turn, aka the deadlock victim, both lanes are now blocked because they access the same resources in a different order.
This can also make it tricky to know when to destroy the memory used by an object. If you're doing manual memory management, this means keeping a counter of how many things reference an object.
Yeah, we used to do this in COM, by the way. That's the way that worked. And this happened all the time and created memory leaks on one side where stuff was not getting deallocated, or it caused access violations on the other side where you're like, here, call this thing on this object that isn't there anymore.
It's funny because I was having this conversation with our lead UI developer when we were between interviews today. We were talking about the different computer science majors, and he was saying how he wished he had gone more business focused than math focused. Apparently, where he went to school, there's 2 CS focuses, and so. But we were talking about that and got into like the different classes he took, and he was telling me about the low level stuff, and he's like, I don't like managing memory.
Yeah.
Like, I understand. I really do. So if you are doing manual memory management, it means you have to keep a counter of how many things reference an object. And this counter is going to have to be thread safe. Objects typically have no awareness that they're being referenced. So this means threading problems as well.
Yeah, because your counter of how many things are referencing that object, it also has to have appropriate synchronization mechanisms around it so that it doesn't have a race condition.
Now, if you are using a memory managed language, which most modern languages are, this still happens in some manner, but it's usually not your problem, except when it becomes your problem.
Yeah, I mean, I've seen this done with JavaScript, for instance. And people are like, oh, it manages its own memory. It's like, yeah, you can make a memory leak real fast in JavaScript. And that's before you get into all the variable hoisting and all those other fun things that go on in that language. So speaking of JavaScript, the next one is viewpoint issues, or the no you problem.
JavaScript. There is no such thing as a single universal understanding of an entity type across an organization, especially over time. And this is interesting because we've had this conversation at work with the different divisions we work with. Some call something a facility, others call it a location, others call it a client, a customer. Like they're using different terms for sometimes the same object, and sometimes they're using the same term to mean different objects between the different individual divisions that we work with. So for example, a client is different for accounting than it is for shipping. It's also different from a small business that serves other small businesses than it is for a large business serving large businesses with subsidiaries. But the second may evolve from the first and can live side by side.
Yeah. Where I work, we had small businesses as clients, and we still do. But we started getting bigger clients that have subsidiaries and divisions and those kind of things. If we were stuck with our old model, it would get ugly really, really fast to try to keep everything in that same model. Or if we tried to change the model, it would be really ugly on the old clients. So you kind of have to understand that as the business grows, its conception of things is going to change over time.
Developers are second order ignorant of a problem domain when they first start working on it. They can be second order ignorant of things when they've been doing it for over a year.
Yeah, and by second order ignorant, we mean the Dick Cheney thing of unknown unknowns.
Yeah.
We don't know what we don't know.
Mm-hmm. You have reasonable guesses of what's going on in a problem domain, and they will be wrong until they're not as wrong. It's very easy to paint yourself into a corner with initial wrong understandings, and it can be a lot of refactoring to get out of them. So what I was talking about earlier, where we had that data problem from the migration, something just got migrated to the wrong place, and it had a reference back to the wrong grandparent object. I get the bug report from UAT testing. It's from the business side of things, and they're like, "Hey, when I enter this, it's not showing up in the list." And that's all they know. They don't know the deep level stuff. So I spent hours looking at the code, trying to figure out, all right, why is this getting the wrong reference ID in only this one place? And I'm like, is it something that we were testing and forgot to remove, like something hard coded in? Where is it getting this number? Is it using the wrong reference ID? And it took a while to figure out, the data got put in there wrong. If one exists, we're pre-populating this information when you create another grandchild object.
Yeah. And it's really, this is an insidious thing, right? Because when you have certain words that are supposed to mean things and they don't mean the same things across an organization, it's always subjective anyway, but it can actually be an organizational fault line. Like if accounting, if the person in charge of accounting doesn't like the person in charge of shipping, and their definition of customer is different, and you're in a meeting with the two of them, you better get braced.
This can also make you a pawn of organizational politics, even though you're just trying to design an object model. Now your code has become political. So speaking of political, the next situation we're going to talk about are behavioral issues, or the criminal minds problem.
Hence the transition from political. Modeling behavior can be difficult to get right in an object-oriented paradigm, because you have to start thinking about things like who owns behavior that involves two entities. Think of your English class in school. Is something passive, voice, or active? It kind of changes the model if you think about it that way. And this isn't going to be the same across departments either, right? Like Accounting, for instance, may say, okay, they made a purchase, and then shipping may say they received a shipment. For instance, there's the aspect of agency that comes into the mix.
It's interesting. I was creating an invoice for an advertisement we're going to be running soon, and I used a template. And in the template, it had a place for invoice number, but it also had this PO number, post office box. What? And I looked it up. I was like, oh, it's product order number. And that's when you're invoicing a company, that is the other company's number that relates back to the service or product that you provided.
Right. It's their reference in their database.
Right. And so I had to figure that out, but that's what this makes me think of is that, that PO number.
This is actually a really good example of this because behaviors can sometimes be verbs. You invoice them, and sometimes be nouns. They got an invoice. It's the same thing of, a murder is a noun, but it was a verb whenever whoever framed O.J. Simpson did it, right? It became a noun later for record keeping. And behaviors end up having their own data associated with them. And that may include other objects, the glove that had to fit or you had to acquit, for instance. The invoice, again, was a verb, but the line items on that invoice are properties on this thing that's now kind of a noun.
A murder is also a group of crows.
Yeah.
I was thinking that the whole time.
Yeah.
Behaviors have a tendency to become persistent objects and to involve multiple objects themselves. If something impacts system state in a way that costs money, impacts security, touches personal data, or otherwise involves regulatory compliance, it has to be stored. You want to talk about storing some just ridiculous things? Work in the public sector where you have to store Booleans because you have to have a record of this checkbox was checked. Even though it's like you check this and then put the date in that it was checked, you have to keep the record that it was checked.
Yeah, or
separately from the date.
Well, the other thing you get in healthcare is you got to know who did it, and not just who in the app did it, but what database principal made the change. Yeah. And so you got to do all kinds of crazy audit logging, and that it really complicates data. Data is any piece of data you have is a fountain, not a statue.
Right.
Straight up. It is a thing that is always changing and, moving forward. But, compliance issues turn verbs into nouns. They just do.
The next situation we're going to talk about is relational issues or the indecent prepositions. Similar to behaviors, relationships between two objects can be quite fluid. Is a versus has a will change on at least some of your objects at some point during your application lifecycle.
Yeah, and I'll give an example. I worked at a company right out of college that made test prep materials for the Microsoft exams, and we had a flagship product that was the training materials, and along with that, you had another product that you could buy that was a set of flashcards that was developed later. And so typically we would say, okay, the product is that main flagship product because we had different ones for different exams. If you bought this code, then it had a secondary product hanging off. And that worked for a while until it didn't work, until I got the flashcard stuff done faster than expected, and sales wanted to go ahead and sell it. And because it was hanging off of this other product, they had to rework code to change it from a has a relationship to an is a relationship so they could sell it separately. And this kind of stuff will happen to your object model just over time.
Yeah, I mean, this is one of those times where they did not foresee this being a separate product.
Yeah.
Just like the example I gave earlier where we had these two separate objects that when we got into how the data is being used, we realized, they need to be connected.
Yeah, and here's the weird thing, right, is where do you store a relationship between two objects, right? Like in a database, you would have a join table. But in an object model, it gets kind of weird.
Yeah, this can impact your ability to navigate between objects from anywhere within the graph. But you can introduce circular references as well.
Right, so let's say you have separate objects for I don't know, a husband and wife, right? And you are trying to make navigation between those two things. Well, the wife could have a reference to the husband and the husband to the wife, but then when you serialize it, you have a circular reference. However, if you don't do that, then if you're at the one that doesn't have the reference to the other one, you can't get back. And it gets weird really quick. And then it's also weird when you got dual-sided references like, husband to wife, and you separate those because you got to do it on both objects, and it has to happen kind of in a transactional manner. So if there's an exception that's thrown, on one and not on the other one, now you have incorrect data in your data model, which will eventually propagate down to your database.
Also, how do you handle cardinality of object relationships when there are more than two involved? Things get nastier when an object has one to many, some unlimited number of some other object.
Yeah, like Netflix accounts, right? Like you've got, I forget how many people can be on there. I think it's like 5. But how do you store the cardinality of that relationship? Because now you've also got to enforce a limit on how many can be in that list. And you've got to enforce it in your object model, in your persistence store, and make sure that that doesn't cause a problem when it gets pulled out of persistence, even if business rules have changed. So like all of a sudden, let's say Netflix, they drop the hammer on these people sharing and they go, you can only have 4. Well, somebody with 5 just got saved a while ago. You're pulling their record up and now the object model doesn't match that rule anymore. What do you do? And you'll run into this kind of stuff a lot. And it also gets weird when you start doing validation, because if it's a relationship between several polymorphic classes, so, like there's a parent account type and there's children account types, that could be really, really strange too, to validate that.
So next is speed and memory issues, or the traffic problem. Object-oriented programming is going to be slower than direct function calls in a lot of cases.
And that's what Linus was complaining about in the kernel. Mm-hmm. Like at kernel level, you just can't have anything inefficient ever.
Right. Every abstraction has a cost. Like you said, when you're writing to the OS, you can't have any of those. Low-powered computing makes object-oriented programming difficult. Now, most of you guys probably are not writing to the kernel in your day job, but you may be using connected devices that you're writing to. You may be doing things where you're working with sensors, or, my opinion, the next big thing, IoT wearables.
Yeah.
Like, I think that's, we had the mobile, and now mobile is becoming super powerful. I think the next thing that we're going to have to deal with is the wearables and how to write to those. You may find yourself creating a large object when you only need 1 or 2 of its properties, because that's just simpler.
Yeah, I mean, this is kind of, this is a developer laziness thing, but like if you're pulling something from the database, it's easier to grab the whole table. It's not better, but it is easier, and people do this over time. You could easily write something where you're not loading a large object, but in practice, that's not what happens.
Didn't you work at a place where you had to fix some code? I remember the story you telling about where a guy had 3 or 4 different places he needed one piece of data, and he pulled back this whole huge, deep object 3 or 4 different times within one call.
I don't remember. Okay, so you're saying, didn't I work at a place like that? Every place I've worked at has had that.
Okay. Well, I just remember you telling a story like that where it was just like this ridiculous thing that was going on where it was, he needed like one flag.
Oh, like a bit field, and he pulls back like a varchar max off of the table and other stuff. Yeah, that's happened at most places I've worked too. It's one of those things. It's like, it's one of those points of reflection where you go, when somebody realizes they've been in a lot of dysfunctional relationships, that it's not really the relationship anymore that's the problem.
So what'll tend to happen with this is that you're going to find yourself using flyweight patterns and things like that for these heavy objects, which adds more complexity to the code. If an object is particularly difficult to construct and you don't need the parts that are difficult, you'll end up using other patterns to avoid that. These patterns will complicate your code, especially if they're done frequently.
Yeah, and what happens when you have a flyweight and all of a sudden now you need something off that other object? You're still going to have to go get it. The flyweight still exists. If it's changed in the database, if the thing that it's actually referencing is changed, you got to make sure and update the flyweight. If one of the two of those changes, you got to update the other one. If there's persistence, there's just all these weird things that start happening. And that gets pretty awful pretty quick. Now, the last one we're going to talk about is advocacy issues. And this is what we call the loudmouth issue.
Pushing object-oriented programming on non-developers is tricky in most non-tech organizations.
Yeah, nobody cares about your object model at all. We should make a bumper sticker that says that.
Remember that the object-oriented part of the project is your interface, not the one that clients are using. That means that it's not going to be a focus, and you're going to annoy people by trying to make it the focus. This is why where I work, when we have our sprint planning, we have our subject matter experts in there to answer any last minute questions and things. But we don't talk about our view model and our object models until everybody else is gone.
Yeah.
And it's just the developers there. We reserve the room for an extra 30 minutes for us to sit there and discuss what we're going to build. But, our product owner, our business analyst, our subject matter experts, they don't care. So long as it presents the way that they want it to present on the screen and it stores the way they want it to store in the database, they don't care about what goes on in between.
Yeah, it's a black box to them. And if you want freedom to code, you need to keep it that way.
You will be refactoring as your understanding improves. Oh my goodness, I did not realize how much you do this until I got out into the real world. Clients don't understand that. I didn't understand that as an apprentice developer until I was out for a year or so in a real job. Not that working with Will isn't real, but in a legit job that I had to go back and refactor things because, we didn't realize that these two things were connected until we got later on.
Or we didn't realize that some goober was going to connect them 6 months from now.
Right. That happens.
Yeah. This is why I beat the drum about never, ever putting refactoring as a line item on an invoice. Because you do that, then clients start reaching into your process and telling you not to do it anymore. It's the same thing with the way you do your object model, any of this other stuff. You're a professional. Do the thing. Don't ask the client's permission. You don't have to ask permission to do it right.
Yeah, it's very easy for refactoring to be the result of semantic differences rather than actual required feature set changes. And you don't want to burden your client or your business people with that information.
Yeah, and they're just not going to get it, right? You're going to spend so much time trying to explain it that you could have already gotten it done most of the time.
Right. Also, you're going to be dealing with a lot of people who are doing it wrong, including, especially yourself 6 months ago. I can attest to that. I've only been doing this for 3-4 years now. And yeah, that 6-month rule tends to be pretty correct.
Yeah, wait till you've had that experience that 6 months ago my code sucked, and you've had that experience more than 30 times.
Yeah, that'll be fun.
Yeah, then you realize that it's never going to get better. So a lot of folks, including those in computer science programs, got an introduction to OOP, and that's all they get. Consequently, a lot of really idealistic notions kind of come out in this sort of design, especially with people that are just out of college, but you'd be surprised how many old senior devs still have this. And you're going to be arguing with these people all the time.
We'll couple this with management not caring about your object model, and you can kind of see the potential for this to blow up in your face. Now, guys, object-oriented programming is a commonly used paradigm, but there are pitfalls out there for the unprepared. Not only can such issues point towards problems that you should avoid, even if you're going to build things using object-oriented programming, but they can also help you avoid using OOP in situations where it isn't appropriate. Like most other paradigms, some issues are intrinsic to the practice, while others are problems with common means of implementing it. There is a lot to be learned from critics and criticisms of things. That pretty much wraps it up. Before we close everything out, Will, what do you have for us this week for Tricks of the Trade?
Well, I just want to point out a really valuable strategy that I use because I do find criticism to be useful of a paradigm, of a language, of a platform, whatever. Go to Google and search for, whatever the thing is, sucks, and then read those articles. Because what this will do for you is it will force you to deal with the problems head on so that you can actually mitigate them instead of getting nailed by them, 6 months from now. You'll find that criticism like this is useful for developing a better way of doing things. You do have to be careful not to be ruled by it, but it is very valuable if you go out and you elicit that first from the get-go. And this, by the way, works in the way you design things. This works with your diet. This works with just the way you conduct yourself in general. Like, always be looking for criticism of the way you're doing stuff, and you'll probably end up better off than somebody that ignored it. That's all I got.
Stand by for Titanfall.
If you have a question or comment, please email us at neckbeards@CompleteDeveloperPodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed through Creative Commons.
The intro music for IoTs is Hillbilly Hip Hop by Jason Belcher. For references, show notes, and to sign up for weekly emails with extra tips and insights, be sure to check out the website at CompleteDeveloperPodcast.com. You can also follow us on Twitter at CompleteDevPod and like our page on Facebook to keep up with news about the show. Catch us each week as we broadcast live, talking about what's going on in the tech world and answering listener questions.
Learn more about all of our shows and groups by going to CompleteDeveloperNetwork.com, where you'll find links to Junior Developer Toolbox, Developer Launchpad, and our other communities. Thanks for listening. See you next time.